Alright, good evening. We'll be taking a look at this topic, organic chemistry. I know a lot of students have challenges with this topic, but I must say this topic is simple. Now, organic chemistry is just the aspect of chemistry that deals with carbon and its compound, majorly hydrocarbons, that is carbon and hydrogen. Now, organic compounds are generally classified into two, which is aliphatic and aromatic. Now, the aliphatic are just chain. They are just organic compounds that are in chain. Then the aromatic are the organic compounds in ring. So this makes it very easy for you. Now remember, in chain you could have a straight chain, that is a necklace that is opened. So you can have an open chain. Then you can fix the chain to have a closed chain. So if you have an open chain, we call that acyclic. That is not cycle, acyclic. Now, if you close the chain, like your necklace, if you close it, it forms a cycle. So any chain that is closed is called cyclic. So like I was saying, you have the ring and you have the chain. A closed chain is cyclic because it forms a cycle. Then an open chain is acyclic. Then we have the aromatic, which are the ring. Example here is benzene. Now, under this we have, for this acyclic, the form two major compounds, which are the saturated and the unsaturated. Now, under the saturated is where you have the alkanes, and here you have the alkenes and alkynes. So, this chart helps to fully understand what we'll be doing in organic chemistry. So, these are the major basics, these are the foundations of chemistry. So if you understand this chart, then it's easier for you to understand. Now, before I go further, I said organic chemistry is the chemistry aspect that deals with carbon and its compound. So there is need for us to understand carbon in order to understand organic chemistry. So I will be taking time to explain briefly on carbon. Now, if you check hydrogen, helium, lithium, beryllium, boron, carbon, the atomic number of carbon is 6. So you have carbon with position number 6. Now, with the old electronic configuration, we arrange it to 2, 4. Now, I believe you have basic knowledge in chemistry. Now, for this element to be balanced, to attain stability, it has to go to what we call octet configuration. That is octet configuration, that is having 8 electrons in the outermost shell. Now, for this to have 8 in its outermost shell, it needs to gain 4 electrons. So, in the modern electronic configuration, we can have it like this: the 1s2, you can have 2s2, then 2p. Out of the 6, you have arranged 4. Then this is a degenerate orbital. So you have 2 other electrons, so we can put 1, 1. Remember, you have to put 1, 1. According to Abba's principle, you have to single fill before you double fill. But then, this is the ground state electronic configuration. Now, this electron will jump over here. That is chemistry for another topic. So, one electron will jump from here down here. That is what we call excitation. Excitation is the movement of electron from penultimate orbital to ultimate, that is second to the last to last. Remember, we have 1, 2, so this was empty before. So one electron jumping from here, the one jumping from here. So we have 4 empty spaces for electron in each of these orbital and suborbital. So therefore, you have spaces for bonding. So you have these 4 spaces. So this is what we call the excited state of carbon. Now, you need not bother yourself with this because this is not really what we are doing. Let me just use this basic to explain to you. Now, I have just shown you that it needs 4 electrons to attain what we call octet configuration. So, therefore, carbon needs 4 electrons. That is why for every carbon atom in organic compound, you must see 4 bonds. 4 bonds. Because the 4 electron that is needed. So for instance, you have something like that. You can have something like this. 1, 2, 3, 4. I can't add this. It will be 1, 2, 3, 4, 5, which is wrong because it needs 4 electrons. So what I'm saying in essence is the bond here signifies the number of electrons. So that is why you have structures like this. You could have structure like this. Now for this now, I will just need to put 1 bond here to make 3, 4, 3, 4. So this should give you some knowledge as to where we are going. We'll continue from here next class.